So you scroll through a bunch of videos on YouTube or TikTok and you see really cool inventions made by one or a few people. Or maybe you've always wondered how your smartphone computer is able to do so many things, from streaming videos to playing games or even talking and receiving calls. Well, I had always wondered that too. It was something that always intrigued me. Like, how does this drone work? Sorry, I just really wanted to show you guys my Christmas gift. But basically, most of these electronics can be categorized into two types of computers: microcontrollers and microprocessors. Stuff like your laptop, PC, and smartphone are made from those microprocessors, and they need a lot of power and performance to carry out its tasks. In this video, I'm not talking about microprocessors, but I'll be talking about microcontrollers, as they're a whole separate topic. But microcontrollers is what I'll explain in this video, and it's something that you can make. Yes, you. So let's begin. Now, what is a microcontroller? In short, it's a device that does one specific task. While microprocessors do multiple things at once, microcontrollers do one thing at a time, due to its power and memory. An example of microcontrollers used in our daily lives can be traffic lights or a smart doorbell. See, one thing at a time. You don't see traffic lights doing multiple things. But you might ask, Emmanuel, how can I code my own microcontroller? And frankly, it's quite easy. Meet the Arduino Uno, or the Raspberry Pi Pico, or the ESP32, or the Teensy, the latter of which I don't have. What I'm trying to show you is that there's so many boards available in which you can create projects and do some really cool things. For example, the Arduino, the most popular microcontroller, has female pins on the sides which are used for plugging in components such as LEDs, motors, and cables. You plug in the Arduino through USB, and that's also where you drag and drop code to the Arduino. The Raspberry Pi Pico is a board that's a bit different to the Arduino due to the fact that it doesn't have any female pins in which cables and components can be connected to. But it has male pins or headers in which you solder to and connect to a breadboard. Soldering is basically heating up solder spool until it comes into contact with the two things you're trying to solder, so that they permanently join together. A breadboard is basically a PCB, printed circuit board, the things that make your device work. Except it doesn't require soldering, so no permanent connections. It's fast, simple, and essential for prototyping. Back to the Pico though. So this board is a lot more powerful than the Arduino, purely in the fact that it has more RAM, allowing for your programs to be speedier, more storage, allowing you to store multiple programs compared to the Uno's one. So overall, it's very powerful and inexpensive, often being cheaper than the Uno. So I just ran through two boards that can be used for making electronics. That's great and all, but how do I code them? How do I make these boards do what I want with them? IDEs. Just IDEs. An integrated development environment is where you'll be creating your code. For the Arduino Uno, the most popular one is, you guessed it, Arduino IDE. And for the Pico, it's Thonny. These both allow you to control the boards and power the components that you need. For instance, you can make an LED blink through the IDE, or make a motor spin. But what happens if I want to do something like control a screen, or make a bunch of RGB lights blink? Simply, you'll need something called libraries. Libraries allow you to control components that aren't as simple to code initially, but because people created files that like the ones you can make, they're now just as easy to program. Check the 0.96-inch screen. It works because there are libraries that communicate to the display and allow it to be easily controlled by the IDE. Okay, that's the basis of the IDE. You're now able to pick a board and code it. Now, I understand that I may have not been in-depth in many areas, such as the fact that there's thousands of components online, each with different features and specifications. The pins on the board you'll be coding also have some differences. They aren't all the same. Some pins power your components while others ground it or allow you to control the component through power. It's also useful to note that there's communities that surround these boards. They're able to help you with any problem you have and are all great at helping each other out. Personally, when I have problems with my projects, I jump straight to forums, which are open messaging platforms to diagnose your issues. So in conclusion, electronics might sound very big and scary, and sometimes it is. I look at projects of people making drones, intelligent robots with AI, and other stuff like that. But just remember that most of those things can be derived from a board just like this. And if you're able to make a light blink on and off, then you can certainly make any project you can think of. I remember when I coded my first project ever on a microbit when I was 13, and now I'm making my most ambitious project yet, in which I'm making a smart clock which not only tells the time, but tells you the weather, connects to your phone through Bluetooth, and so much more. Hopefully I can finish it though, so fingers crossed, but alas, I hope this year will be your best year yet, and will hopefully be the start or continuation into the amazing and rewarding world of